All right, so you know when you finally figure something out in Python and it's like a light bulb moment?
Yeah, totally.
Like maybe you just got nested statements to work the way you wanted,
Huh?
or you got onKeyPress doing its thing, making stuff happen when you tap a key.
Yeah, I love that feeling.
Okay, well get ready because today we're going to take that to a whole other level of interactivity.
Oh, nice. What are we diving into?
It's called onKeyHold, and it's kind of like onKeyPress, but instead of just one tap, it keeps going as long as you're holding the key down.
Hmm. I think I'm starting to see where this is going.
So imagine like holding down an arrow key to move a character smoothly across the screen instead of just one jump at a time.
Oh, yeah, that makes sense.
So that's what we're going to explore in this deep dive, how onKeyHold works in Python and what kind of cool stuff you can do with it.
Cool. So like games and animations and things like that.
Exactly. We'll even point out some common mistakes to avoid so you don't get stuck along the way.
Sounds good.
Yeah.
I'm ready to jump in.
Okay. So first things first, let's just see what onKeyHold actually does.
Right, because it might sound simple, but it's actually pretty powerful when you start using it.
So our source has this first example that's super basic. It's just a counter that goes up as long as you hold down any key.
Oh, cool. So like I can just run the code, press any key, and watch the numbers climb.
Yep. And keep holding it down. You'll see it doesn't stop until you let go of the key.
Huh. So that's how it's different from onKeyPress.
Exactly. With onKeyPress, you'd have to keep tapping the key over and over to make the counter go up each time.
Yeah, like you're clicking a button.
But onKeyHold is listening for that continuous pressure on the key, and it keeps triggering the action again and again.
Okay, so it's like holding down a button on a game controller to make your character keep moving in a direction.
Perfect analogy. It's that kind of constant action that onKeyHold gives you.
Now, how does onKeyHold know which key I'm holding down?
Good question. You might notice in the code it uses this thing called keys with an "ez" at the end.
Yeah, I saw that, not just key like with onKeyPress.
Right. So even if you're only holding down one key, Python actually sees it as part of a group or a collection.
Huh, interesting.
You can almost think of it like keys is a little bag, and Python puts all the keys you're currently holding down into that bag.
A bag of keys. Okay, I like that. So even if I'm just holding down the A key, it's in that keys bag.
Exactly. So then the question is, how do we check if a specific key is in that bag?
Right, because we don't just want anything to happen. We want to know if it's a specific key.
And this is where a really handy tool comes in called the in operator.
An operator.
Yep. It's super useful for this kind of thing, and the second example in our source shows how it works.
Okay, what does it do?
So in this example, the counter only increases if you're holding down the Z key.
Only Z got it.
And the key part of the code literally says, if Z in keys.
Oh, so it's like asking, is the letter Z inside that keys bag?
Exactly.
So if I run this code and I hold down, and nothing happens, but if I hold down Z, the counter starts going up.
You got it. Now, our source also mentions a really common mistake people make, especially when they're first learning this stuff.
Oh, I bet I've made it.
It shows a broken example where someone tries to check the key using if keys equals Z, like they're comparing the whole bag to just the letter Z.
Oh, yeah, I can see how that would be tempting.
But why doesn't that work?
Is it because even if I'm only holding down Z, that keys thing is still a bag, even if it just has one thing in it?
You're absolutely right. And in Python, that bag is called a list.
List, okay.
And you can't directly compare a whole list, even if it has just one thing, to the thing itself.
Like asking if my backpack is an apple instead of asking if an apple is in my backpack.
Perfect analogy. That's why you get an error message in Python that says something like, error, you must use the in operator here, or error, lists cannot equal strings.
Okay, so always use in to check if a specific key is being held down.
Got it. Now let's take it up another notch. What if we want something to happen only when we hold down two specific keys at the same time?
Ooh, two keys. Now, this is getting interesting.
And this is where those compound conditionals we learned about before come in handy.
Oh, right. Using and, or.
Exactly. So the source has this example where the counter only goes up if you're holding down both the Z key and the X key.
At the same time.
At the same time, yeah?
So how does that look in the code?
It looks like this. If Z in keys and X in keys.
Ah, so it's checking if both Z is in the bag and X is in the bag.
You got it. And just like with our regular if statements, that onKeyHold function will only do its thing if both those conditions are true.
This is really starting to click for me now.
Now, the source also throws out this little brain teaser, what would happen if we used or instead of and in that code.
Let me think.
What do you think?
Okay, so if it was EA, or the counter would go up, if I was holding Z or X or even both.
Right. Exactly. So even though it's just a tiny change in the code, it makes a big difference in how the program behaves.
Yeah, that's a good way to think about how and/or work.
Right. Okay, so we've seen how to detect single keyholds and multiple keyholds. Now, let's think about what we can actually do with this continuous input.
Yeah, because knowing which keys are being held is cool, but we want to make something happen.
Absolutely. And one of the coolest things, especially for games or interactive art, is moving shapes around on the screen.
Ooh, yeah, like making a character walk around.
Exactly. And the source has this great example where a little blue circle moves to the right as long as you're holding down the right arrow key.
So simple, but so effective.
Right. And the code for it is pretty straightforward, too. Inside the onKeyHold function, it just checks if right in keys, and if that's true, it makes the circle's center X value increase, which moves it to the right.
Oh, that's cool. So instead of just jumping a set distance with each press, like we might have done with onKey press, now the movement is smooth and continuous as long as you hold the key.
Exactly. And think about how you could adapt this to other arrow keys.
So to make it go down, if I hold down the down arrow key, I would check for down in keys.
Yep. And then you'd probably want to adjust the circle's center Y value to move it up and down.
Yeah, instead of center X, I'm getting it.
Awesome. Now let's get even more creative. What happens when our moving circle hits the edge of the screen?
Oh, that's a good question. It just disappears.
Well, it could, but our source introduces this really cool concept called wraparound.
Wrap around.
Yeah, it's a neat trick that makes your little interactive world feel more seamless.
Okay. I'm intrigued. Tell me more.
So imagine that circle moving to the right. When it reaches the right edge of the screen, it instantly pops up on the left side like it wrapped around.
Oh, that's cool. Like a video game world where you keep going and going.
And exactly. And to do this, we can use those nested conditionals we've been learning about.
Ooh, nested conditionals for wraparound. This is where it gets really powerful.
Right. So first, the code checks if right in keys. So if you're holding down the right arrow key, then it moves the circle to the right by increasing its center X value like we talked about before.
Okay, that's the first part.
Now here's the nested part. Inside that first if block, there's another if statement that checks if ... left is greater than or equal to 400.
So it's checking if the left edge of the circle has gone beyond the right edge of the screen.
Exactly. And in this example, the right edge of the screen is at the X coordinate 400.
Got it.
So if the circle's left edge has gone past 400, it means it's off the screen to the right.
So what happens then?
Then the code sets the circle's ... right property to 0.
So it basically teleports the circle back to the left side?
Yep. It puts the right edge of the circle back at the very beginning of the screen, making it look like it wrapped around.
That's so clever. I love how that one little nested if statement creates that wraparound effect.
It's all about breaking down the logic step by step. First check if we're holding right, then move it, and then if it's gone too far, reset it to the other side.
Okay, so nested if statements really help make the code more organized and easier to understand.
Totally. Now, the source mentioned something interesting. What if we change that movement amount from 1 to 10 each time the key is held?
So instead of moving 1 pixel to the right, it moves 10 pixels every time.
Yep. What do you think that would do?
I think it would just make the circle move way faster across the screen, right?
Exactly.
Yeah.
It's a simple change, but it has a big impact on the speed of the animation.
Cool. Now, what about testing all this? I imagine it can be hard to see exactly how much things are changing with each keyhold since it's happening so fast.
That's a really good point. It's not like a single key press where you get one clear action. Holding down a key can trigger tons of updates super quickly.
Yeah. So how do we make sure everything is working the way we want it to?
Well, our source mentions a special function that can help with this called onKeyHolds with an "as" at the end.
onKeyHolds.
Yeah.
Okay, that's something we would use in our regular programs?
Not really. The source emphasizes that it's mostly just for testing.
Oh, okay. A testing tool.
Exactly. So what onKeyHolds does is it basically pretends that you held down a specific set of keys for a certain number of times.
So it simulates holding down the keys.
Yep. And that lets you see the total change that happened after those multiple simulated holds.
Makes sense. So we can see the bigger picture.
Right. And in the example, the source shows how you can uncomment a test case that uses onKeyHolds with the right arrow key and a count of 5.
So it's like running the code as if I held down the right arrow key 5 times.
Exactly. And then you can look at how much the circle's position changed in total after those 5 simulated holds.
So I can see if it moved the right amount.
Yep. And if you divide that total change by 5, you can figure out how many pixels the circle moves each time the right key is held down.
Ooh, that's a clever way to test it.
It's like a slow motion replay for keyholds, so you can see what's happening step by step and make sure everything is working as expected.
I'm definitely going to be using that when I'm working on my own projects.
So to wrap things up, we've taken a pretty deep dive into onKeyHold today and seen how it's different from onKeyPress by triggering actions repeatedly as long as a key is held.
Yeah, and we learned all about that keys list and why we have to use the in operator to check for specific keys.
We even saw how onKeyHold can work together with those compound conditionals using and/or to respond to multiple keys.
And don't forget about nested if statements for making things like our wraparound example.
Right. And of course, we can't forget about that handy onKeyHold's testing tool to help us make sure everything is running smoothly.
So what's the big takeaway here?
Well, I think the coolest thing is how all these different concepts, onKeyHold conditional logic, even what we learned with onKeyPress, all work together.
They're like building blocks.
Exactly. Each piece builds on the others and lets you create more and more complex and interactive programs.
So now that we know all this, what kind of projects can we actually build?
That's the exciting part. Think about it. You can use onKeyHold to make a character in a game move faster the longer you hold down a button.
Ooh, or maybe you need to hold down multiple keys at the same time to activate a special power-up.
The possibilities are endless.
Right.
It's all about getting creative and experimenting with these tools to see what you can come up with.
That's what I love about coding. You can make anything you can imagine.
Well, that's our deep dive for today. Hopefully you learned something new and got some inspiration for your next Python project.
Until next time.
See you later.